Okay, earlier this semester we reviewed how to solve systems involving two linear equations. We've been working with quadratic equations the last couple weeks, so what we're going to finish up this unit with is looking at solving a system where one of the equations is a linear equation, a line, and the other is a quadratic. So our objective is to solve systems of equations involving linear and quadratic equations. So let's talk about linear and quadratic systems where the quadratic only has one variable. Remember that we want to make sure that we understand that a solution to a system of equations graphically means where the lines intersect. So keep that in mind. The solution to a system is where the lines intersect. So if we're talking about a quadratic in one variable, essentially that is a parabola. So a linear quadratic system can result in one of the following three situations. Remember that the graphs of linear equations are lines and the graph of quadratic equations in one variable are parabolas. So essentially we're looking at the possibilities of a line and a parabola intersecting. We can see in the first situation that your line could intersect your parabola in two places. So there and there. Those are two real solutions. Your line could intersect your parabola in one location. That would be one real solution. And then you could have the situation where your equations do not intersect. So in that case, we would have no real solutions. Please note that for our purpose, we're just going to stick with situations that have at least one or two real solutions. Understand that there are situations where there might be imaginary solutions, but we're not dealing with that. So with that being said, let's look at the first system. We have y equals x squared minus x minus 6 and y equals 2x minus 2. So the first one's a parabola. First one's a parabola. And the second one is a line. I would like you to put those two equations in your graphing calculator just to get a visual. So y equals x squared minus x minus 6 and 2x minus 2. And graph both of those. You'll see your parabola first and then your line. So you can see in the picture that we should have two real solutions because they're intersecting twice. So let's look at how we get those two solutions. Because both of those quantities equal y, we can set those two expressions equal. Since this quantity is equal to y and this quantity is equal to y, then they must be equal to each other. So x squared minus x minus 6 equals 2x minus 2. Okay, we have a quadratic. We're going to get everything on one side, and then we'll try to factor if we can, if not quadratic formula. So subtract the 2x and add the 2 is what I'm going to do. That gives me x squared minus 3x minus 4 equals 0. This is a quadratic that does factor, so we can go ahead and factor to x minus 4 times x plus 1. So the two x values that I'm getting are 4 and negative 1, which makes sense because I know that I should have two solutions, two ordered pairs. So hopefully these are the two x values of my two ordered pairs, my two solutions. So from those x values, we need to find the y values. So what we're going to do is we need to make sure that these two values of x produce the same values of y for our two functions. So I kind of set up a little grid, and I am going to use x equals 4 for one column, and I'm going to use x equals -1 for another column. So in the first column, I'll plug in 4 for the first equation. So that would be y equals, that would be 4 squared is 16 minus 4 minus 6. This is 12 minus 6 is 6. So for the first equation, when x is 4, y is 6, so that ordered pair is 4, 6. Let's make sure that we get the same y value when x is 4 for the second equation. So y equals 2 times 4 minus 2. That's 8 minus 2. That is also 6. So we are getting the same ordered pair. So 4, 6 has to be one of our solutions. Now let's do the same thing with -1. Plug in -1 to the first equation and the second to make sure we're getting the same y value. So this would be -1 squared is 1 minus a -1 is really +1 minus 6. So this is what, -4. So -1, -4. Let's make sure we get the same thing for the second one. Y equals 2 times -1 minus 2. That's -2 minus 2, that's -4. So we are getting the same. So those 2 points that we saw on our graph at the beginning, the points where we have the two functions or equations intersecting are these two ordered pairs. So those are the two solutions. I want you to stop the video and I want you to try number 2 on your own. It works very similar to the first one. Stop your video now. Hopefully you tried this second system on your own. The two ordered pairs or solutions that you should have had are 4, -8, and -1, 2. All right, let's go ahead and move on to a different type of system, and this will be the only other type that we look at. So now we are going to look at, again, a linear equation, but this time we are going to look at a quadratic equation that has two variables, okay? So the type of quadratic and two variables that we are looking at is a circle. So similarly with one variable, there are different solution situations that can occur, and again we're going to stick with examples with 1 or 2 real solutions. So as you can see here, we have x squared plus y squared equals 25 and 4y equals 3x. Now, what I would suggest to you is that we solve this second equation for a variable. It could be x or y, it really doesn't matter. If we divide both sides by 4, we get y equals 3 over 4x. Now that I have a variable by itself, I can take this quantity and plug it in to y. So this is essentially substitution, just kind of on a little bit more difficult scale. So let's rewrite this first equation plugging this value in. So we'll have x squared. Now instead of y, I'll have 3 over 4x squared equals 25. Now we're down to one variable that we can solve for. So we have x squared plus 3 over 4x quantity squared is 9x squared over 16. That equals 25. Now, I want to clear my fractions. Think about all of this being over 1. So if I clear that fraction, I can multiply everything by 16, and then all of my fractions are cleared. So this would give me 16x squared plus 9x squared equals 400. From here, 16x squared plus 9x squared is 25x squared equals 400. Divide both sides by 25, so x squared equals 16. Take the square root, x equals plus or minus 4. So those are the two possible x values that we have. So then we want to go back to our little chart, x equals 4 in one, x equals negative 4 in another, and plug those in. So for 4, let's go here, and I'm plugging 4 in for x. So this is 4 squared, which is 16, plus y squared equals 25. And then I'm solving that for y. So essentially all I need to do is subtract 16, which is 9, and take the square root. When I plug positive 4 into the other equation, so y equals 3 over 4 times 4, that gives me the y value of 3 again. Okay. When you take the square root of this 9, I know it's plus or minus 3, but we want to pick the one that matches up here. So we want to pick the positive 3. So one of our solutions is 4, 3. Once you plug in negative 4 to the equations again, for the first one we would have 16 plus y squared equals 25. In this case, we want to pick the negative 3, which is hard to know at first until you plug it in to the second equation. So y equals 3 over 4 times negative 4 gives us the negative 3. So we know we wanted to pick that negative 3 first. All right, I'm going to let you try this last one on your own. Hopefully you gave that one a shot. This one was a little bit more difficult than the first one because you end up with x or y, depending on what you solved for, being a quantity. When you plug that quantity in, you have to multiply out that binomial. When all is said and done, I ended up solving for y first, but you may have done it differently. But when all is said and done, the two solutions that we should have are -1, -5, and 1, -5.